All right, so let's dive in. Our mission today is a deep dive into the sun. We want to get past that image of just a big yellow ball in the sky and really correct some of the biggest mistakes people make about our star.
Exactly. And I think the first one we have to just get out of the way immediately is this idea that the sun is a planet.
Right?
Is not. It's a star. And its structure is key. It's made of this intensely hot plasma.
Not just gas.
No, plasma. It's the fourth state of matter, and you need that plasma state for the thermonuclear fusion happening at its core, which is running at an insane 15 million Kelvin.
An insane temperature. But the scale, I think, is what's really hard to grasp. I mean, the sun contains almost 99% of the entire solar system's material.
This is dominant.
Completely. You could line up 109 Earths and they just barely stretch across its diameter, and light itself takes 8 minutes and 20 seconds just to get to us.
To really get a feel for that, you have to use a scale model. So imagine the sun is a grapefruit, about 12 centimeters across.
Okay, I have a grapefruit.
On that scale, Earth is a pinhead, 1 millimeter. Now you put the grapefruit down, and you have to walk 13 or 14 meters. That's about 43 feet to place the pinhead.
Wait, 43 feet away? A tiny pinhead?
Yes. And that right there shows you how much of space is just empty.
That really drives it home. And that massive scale leads to the next big myth. The idea that the sun burns.
Right. Burning, like a fire needs oxygen. Space doesn't have any. The sun is powered by nuclear fusion. It's turning hydrogen into helium.
And the proof is its age, isn't it?
The proof is its age. It's been stable for 4.5 billion years, and it's got another 5 billion to go. A chemical fire would have burned out in, a few thousand years? Only E equals mc squared, that incredible energy for mass conversion, makes that possible.
So fusion is the engine. Now, let's talk about maybe the most stubborn myth of all, the one that just won't go away, the seasons.
Oh, they were closer in the summer, and it's just completely false. In fact, for the northern hemisphere, we're actually closest to the sun during winter. The real cause is the Earth's axial tilt, 23.5 degrees.
It's all about the angle.
It is all about the angle. That tilt changes how directly the sun's rays hit us, concentrating the heat, and it changes how long our days are. It has nothing to do with distance.
Okay, that makes perfect sense. But the sun itself has some really counterintuitive things going on. I mean, the visible surface, the photosphere, is about 6,000 degrees Celsius.
Which is incredibly hot. But then you get to the coronal heating paradox.
Right.
The sun's outer atmosphere, the corona, is millions of degrees hotter than the surface below it. It makes no sense from a simple heat perspective. Heat should dissipate.
So it should be getting cooler as you move away.
It should be getting cooler. The fact that it gets